Okay, the tutorial 9, first question is on flexible pavement. So in that one, we will discuss about the allowable traffic. Last week, we discussed about the design traffic, if you can remember. Now we are going to find out the allowable traffic. So let's do this question. This will be useful for your circular practical as well. Okay, so these calculations you need to include. You need to do some calculations in the lab report. So you need to know how to do these calculations manually. Certainly do all the calculations by itself, but you have to compare your experimental data with the calculated data. So you need to know how to do these calculations. Okay, so this is our question. So they have, in flexible pavement design, we start with the trial pavement. I told you that last week as well. So they have given us this pavement here. We need to check whether this pavement is okay or not for this given, for the given design traffic. So in the first layer, we have asphalt. It is 200 millimeter thick and the modulus is 2,500 megapascals and it has 11% of bitumen. And then you have a cemented layer of 300 millimeter thick and the modulus is 2000 megapascals and the CBR of the subgrade is 5%. And they have already also given us the design traffic in heavy vehicle axle groups, and they have given these ratios for us to convert from one unit to another unit. You are familiar with those things because we have discussed it last week as well, how to convert units. And again, they have given us micro strains got by Circly. So when you do the Circly practical, I will show you where to find these values for different layers for different pavements. So micro strain for asphalt, cemented and subgrade are given for pre-cracking. So you can see asphalt is 26 microstrain, cemented is 72 microstrain, and subgrade is 170. They don't have units. Strain, you know, strain, I think you are familiar with the term strain in fundamentals of mechanics, change in the length divided by a length, yes. So, and also they have given us some post-cracking strains as well. Critical strains here, 118 for asphalt and 348 for subgrade. So whenever we have a cemented layer, so here we have a cemented layer. If we have above the cemented layer, if we have an asphalt layer with more than 170 millimeters, we need to check the pavement for pre and post cracking both. That means your cemented layer is not be cemented forever. It will crack and it will become an unbound granular layer. I told you last week the critical locations of flexible pavement. Do you remember that? At the end of the asphalt layer, there is that's the critical location for asphalt, and cemented layer again at the bottom of the cemented layer and the top of the subgrade. So the critical locations are in asphalt, cemented, and subgrade. But there is no critical location for unbound granular material. So post-cracking means your cemented layer now has become unbound granular layer. So you don't have a strain for that. You only have asphalt and subgrade after the cemented layer converted to unbound granular layer. Do you understand the question and the things that I have explained so far? Okay, so now let's move on. We are going to find, we are trying to find out whether this pavement is okay or not for this particular design traffic. To compare, when we consider the design traffic, we use the NDT that is given as 5 times 10 to the 8 heavy vehicle axle groups. And we are going to find the allowable traffic for asphalt, allowable traffic for cemented, and also allowable traffic for subgrade. Which one need to be higher? Which one's the allowable? I told you last week as well. Allowable should be higher, isn't it? So whenever the allowable is higher than the NDT, we can say that particular layer is okay. If in asphalt, if asphalt can allow more than what we are designing for, then the asphalt layer is okay. So likewise, we are going to compare different layers and to find out whether the trial pavement is okay or not. to compare, we can't have these in different units. Am I right? So we need to, we should know how to convert the units. So in this one, we are going to use the units ESA. So we are going to convert everything to ESA and we are going to compare the values. So before doing anything, let's first see whether you have remembered the previous week stuff. So can you please convert this to ESA? NDT, how can you convert it to ESA? Do you need to divide by 1.44 or multiply by 1.44? What you need to do? How can you get rid of HVAG part? If you divide, is your HVAG cancelling out or not? Divide or HVAG is in the denominator. You need to multiply, then your HVAG will cancel out and your answer will be in ESA. So what do we get as the NDT in ESA? Yes. So that will be, yes, 7.2 times 10 to the 8 ESA. Am I right? So that will be our design traffic. Whenever the design traffic is less than allowable, we can say that layer is okay. Okay, so we are fine with unit conversion. So we'll move to the next part of the question, which is finding the allowable traffic. So when you are finding allowable traffic, we have three equations. So for the asphalt, we can find the allowable traffic using this equation. Here, RF is the reliability factor. Depending on the project reliability, if you go to the question, they have given us the project reliability for this one, which is 95%. So depending on the project reliability factor can be calculated from the off-road guide. So we are going to use those tables to find the reliability factor. And E is the modulus. So modulus is given to us, which is 2,500. And the microstrain was given to us in the question. For pre-cracking, we need to do for pre and post both. So we are first going to go with the pre-cracking. So pre-cracking microstrain was given in the question as 26. And the binder content is given 11. So when you put these numbers, you can find the allowable traffic for asphalt in the units of SAR 5. Standard axle repetitions 5. So you have this 5 for that because of the repetitions 5. We do 11 or 11? No, we just put 11. Yes, even for modulus and the microstrain. Micro means 10 to the negative. It's not the strain, it is microstrain. So you don't need to do any unit conversions to make the megapascals to pascals or microstrain to strain. So you just substitute the numbers. Okay. So when you substitute, before that, we need the reliability factor. Let's find the reliability factor and do the calculations. So this is the equation for your asphalt, and we have a similar equation for cemented. Here again, microstrain was given to us in the question. For pre-cracking, it is, sorry, for cemented layer, it is just one microstrain, which is 72. And reliability factor we need to find from the road guide. Modulus is given to us, which is 2000 megapascal. So by putting the numbers in the equation, we can find the allowable traffic for cemented layer in the units of SAR 12. Is that right? And then if you look at the subgrade, we have another equation. The microstrain is given to us again. For pre-cracking, it is 170. So let's start with the pre-cracking stage and we'll find all these answers. So to find everything, we have everything except the reliability factor. Let's find the reliability factor and come back to this slide and we'll calculate the allowable traffic. Okay. So when you go here, this table 6.15 and 6.8, they are from Off-Road Guide. So suggested reliability factors for asphalt. So we have 95% of project reliability. So we can find the reliability factor for both cemented and asphalt, it is 1. Am I right? So we can now go and put these values here and we can find the find this allowable traffic. Can you please find me just maybe one For asphalt, yeah, I'll do that then. As 0.856. What do we get?
This one, 7.55.
Don't you get this 1.3 times 10 to the 11?
Oh,
Got it? Okay, now this one is in SAR 5. We have converted the design traffic to ESA. So can you guys please convert this also to ESA? How can we convert this to ESA? Yes. So you just divide by, you need to divide, isn't it? Because, yes, so you need to divide by 1.2. So when you divide by 1.2, I get the asphalt allowable traffic for pre-cracking, which is equals to 1.05 times 10 to the 11 ESA. Is that right? Okay. So now we can't compare at this stage. We need to do a few more steps. There are a few more steps. But if you compare this with the design traffic, what can you say? Okay or not? Which one is higher? So asphalt is allowing more than what we are designing for. So asphalt is okay, but we can't make the decision. We need to go for post cracking as well. Okay, so but you now have an idea what we are doing. Yeah. Okay, so there is another terminology that we are going to use in the practical. So we are going to find the CDF, cumulative damage factor, which is equals to NDT over N. So this one, whenever it is less than 1, we can say the layer is okay. If it is more than 1, the layer is not okay. So CDF means the NDT divided by the N, design traffic divided by the allowable traffic. So that's the part that we are going to use. This is, we are checking the CDF of different layers in circling. Okay, so now let's move to the next one, which is our cemented layer. So can you find me the same thing for the cemented layer? So this one is 72. What do you get? You get this? Got it? Okay. we again need to convert this to ESA. We have to divide by 11.2, isn't it? This is SAR 12. So we need to divide by 11.2 so we can find the allowable traffic. Now, if you compare, what can you say? It's not okay. It's not, yes, it's not okay. Yes, that's right. Okay, now the last layer, which is our subgrade. So you can do the subgrade. The micro strain for pre-cracking will be 170. You can't compare when to compare, we need to have both in the same units. That's why we're converting everything to ES.
If that comes an example, you're gonna get that table with the.
Yes, yes, you get this table. This one you get. Last week we learned how to get this. Do you remember? They are not these numbers will be different for different projects. This should be given to you, and it's not the same for all the project. It depends on your traffic load distribution.
Okay. Will we have to change that? For any of the questions, will they give us a question? Can they give us a question where we have to calculate that?
Yes, because you know how to calculate. We learned it last week.
Oh, that's fair enough. I'll just have to go back to. Oh, yeah, there's like two tables. Yeah. Then multiply them together, and then you add it, and you've got problems.
Okay, do you guys get this? So, yes. Again, we need to convert it to ESA. So we need to divide by 2.08 and we get this 7.04 times 10 to the 11. Again, it is more than the design traffic. So it's also okay. Now, all these numbers that we have calculated, the allowable traffic for asphalt, cemented, and the subgrade are for pre-cracking. And also when we have asphalt layer, which is thicker than 175 millimeters, we have to do for post cracking as well. That means when your cemented layer is cracked, it has become a granular layer. Granular layer doesn't have any critical locations, but we still need to find out the asphalt and subgrade is okay without the cemented layer. Okay, so everything will be the same. The only things changing is your micro strain. So micro strain for post cracking is different. For micro strain for post cracking for asphalt is 118, and the subgrade it is 348. So we just change the micro strain. So you can see micro strain is different. So we have to now redo the calculations for asphalt and subgrade, not the cemented. We don't have cemented anymore. We have a granular layer instead. So we have to check the post cracking allowable traffic for asphalt and the subgrade. So can you find me the asphalt allowable traffic for post cracking? You get this?
Yes.
So when you, again, we need to convert it to ESA. So when I convert it to ESA, I got this. This is for asphalt post cracking. 5.44 times 10 to the 7. Is that right? Now we need to do for the subgrade as well. For the post cracking, the only change here is this 348. We have to put 348 here. So when you put that, you can find the allowable traffic for subgrade, which is 9.74 times 10 to the 9 SAR 7. We convert that to ESA by dividing by 2.8 to 2.008. So that will be 4.68 times 10 to the 9 ESA. Okay, so far we have found this information. All the green stuff are pre-cracking and the blue things are post-cracking. So now we need to find the total allowable loading of pre and post phases using the two equations. So we have allowable loadings for, we have an equation for subgrade and also we have an equation for asphalt. So I have put two different colors for make it easier for you to substitute. You don't need to remember any of these equations, but you should be familiarized with these equations. Sometimes you may put the wrong values. Where you have to put post values, you need to put the post. Where you have to put the pre values, you need to put the pre. I have used two color codes, but in your papers, you get everything in black. You have to read carefully and put the right values in the right place. So will you be able to find me these two? Just one, maybe subgrade, find the subgrade. I will give you the answer for the asphalt. They're both very similar equations. Got it?
Yeah, 4.93.
Yes, 4.93, 10 to the 9 in ESA. They all are ESA. We substitute everything in ESA. Okay, so if you find for asphalt, you get 3.8, 3.08 times 10 to the 8. So you can see when you compare with the design traffic, subgrade is okay, but asphalt is not okay. So we have to make the conclusion saying that this trial pavement is not okay for this particular design traffic. So in Circly, you will find this kind of situation. So in that, what we can do is we change the trial pavement. We can either change the thicknesses of different layers, or else we can add layers, maybe a granular layer or maybe another asphalt layer at the top. So likewise, we can change the thicknesses, we can change the materials, we can change the trial pavement. So we start with the trial pavement, not just without anything. We need to start with the trial pavement and we can proceed after that. Are we good? Any question? Okay, so with that, we finish the flexible pavement part.